So today we're going to be doing these, we're going to do more theorems. We're going to finish up the theorems that we have for this section. This is not the last section of Chapter 2 or Unit 2, but it's getting really close. So we'll have the 2.6 is just going to do some proofs with these, okay? All right, the properties of angle congruence. You have some properties of algebraic properties at the top. If you'll get those open, the top ones, congruence will work with the other ones, and we're not going to worry about if it says congruent or equal for the rest of this. We're going to use them. So reflexive.
Mm-hmm. The top of our note sheet.
Yeah, and the note sheets on, yes. You notice you have on your note sheet, go back here. Right here. Reflexive, symmetric, and transitive is what we're going to talk about right now. I've got reflexive up here. Reflexive can work not just with numbers, but it can work with angle measures too. So reflexive comes about if I have angle A equaling angle A. Okay? Or as congruent in this case, all right? So I don't want you to rewrite these. So what I want you to do on your little note sheets or in your postulate book, I want you to write right above the equal, I want you to put a congruence, so it can be an equal or a congruence, all right? So I don't want you to rewrite these, but and you can also, so anytime you see an equal, you can use reflexive. Anytime that there's a congruent, you can use reflexive. That just means something equaling itself. An angle will equal itself. Another one is symmetric. If I have an angle A equaling angle B, I can turn it around and make it a B equal A. Congruence will work the same. So if I have angle A congruent to angle B, I can flip them around. So symmetric works the same, okay? Transitive works the same also. So if I have an angle B congruent to angle, A equal congruent to angle B, and B congruent to angle C, then I have at the end angle C congruent.
Wait, so are we supposed to write congruent next to all of them?
I would just right above it. I'll right above your equals. I'm gonna borrow this, okay? So right above that equals, I'll just put a little congruent. So it's either or of those will work. Okay? That's what I was intending. Okay. All right.
Does that work for them too?
It works for your reflexive, symmetric, transitive. We're going to use it for the rest of them too.
Is that okay?
Yes, that works.
And then put it down.
This thing is for you, so you do it the way it's going to work best for you. Okay?
Okay.
All right. No stress.
And then you said we're going to use the congruent sign for all the rest of our
We can use the you won't likely use them for anything except algebra, the rest of those, but we could. Okay. Substitution we're going to use all the time. So substitution definitely can be with congruence.
This
okay?
one?
Yeah, we wrote that one in before, okay? All right. I have had multiple different geometry experiences with different textbooks and ideas, and some of them are really picky about the difference between congruent and equal. And they require in proofs for you to go from a step between something being congruent. Then you have to say it's equal. Then you have to do all the algebra with it. And then you have to turn it back into congruent. And I think that's crazy, okay? So I personally subscribe to the idea that we're going to use congruent and equal almost interchangeably, understanding that congruent means the same object or the same shape and size, okay? Or measure in this case, right? Here we go. Here's the other one, the right angle congruence theorem. That should be, it's this couple pages back. You can write, this is in your postulate book. It should be towards the end. We're going to put some pictures with this. It says that if two angles are right angles, then they are congruent. Did you guys rewrite those with your biconditionals and inverses and stuff yet? I can't remember.
Hmm?
Did I have you rewrite this as the converse and inverse in your homework at all?
Yes.
Okay, good. My reasoning was it would get it into your brain a little bit better. Mm-hmm.
With our Unit 2 postulates, and I know that the first page, all of the first page could go in like all of our properties, but then the only other things from that goes in is something that says postulate or theorem.
No, anything else. Everything else goes in there. All of those go in.
Oh, I thought it was just the first page. And
I understand.
The postulates and
These are actually postulates. They're just not they don't have names like theorem, like this right angle congruence theorem don't. So those do. Okay. All right. All right. If two angles are right angles, then they are congruent. There's a picture to demonstrate this. So the question was, what does that mean? That means that if angle 1 is 90 degrees, it's right angle. If this one, number 2, is also a right angle, it seems logical that I should be able to write, come on, I should be able to write that angle 1 is congruent to angle 2 because they're both right angles, okay?
Wait, so are we supposed to like write this here?
You could draw this picture if you wanted, and you can draw that if you want. It's totally up to you. Questions? It's got a title. It's called the right angle congruence theorem. Here's another one. This is the congruent supplements theorem. Go ahead.
Can you go back to
Yes, I can. If two angles are supplementary to the same angle or congruent angles, they are congruent. So I am going to first say that an angle 2, is this obtuse right?
Obtuse.
It's obtuse, okay. And so I'm going to just pick a number out of the sand, okay? And I'm going to say this is 120 degrees. You can't even see that because my colors are changing. 120 degrees. All right. If I said that these two are supplementary, what does it mean to be supplementary?
They equal 180.
They equal 180 together. They add up. So if angle 1 and 2 add up to 180, what does that mean angle 1 must be?
60.
You agree? Yes. Thank you, Brett. All right. If I say that angle 2 and 3 are also supplementary, so what does angle 3 have to be?
60.
60 degrees. What does that mean about angles 1 and 3?
They're congruent.
They are congruent. Now let's look at the statement. If two angles are supplementary to the same angle, that meant that angle 1 was supplementary to 2, and 3 was also supplementary to 2. If two angles are supplementary to the same angle, then they are congruent. So if I have two angles, and they're supplementary to an angle outside of itself, then they're congruent to each other. If you need to draw those pictures on your pages or in your postula book, please do.
For now, can I just take a picture with my phone?
Yeah, and you'll also be able to watch the videos. I'll put them up too. You can watch
Okay,
me.
I just want to
Yeah,
write
go
them
ahead.
later.
Okay, here we go. Here's our next one. Now we have the congruent complements theorem. What does it mean to be complement or complementary?
Equal,
90.
it's
They equal 90.
They add up to be
90.
90 degrees. Okay, so here we go. If two angles are complementary to the same angle, or to congruent angles, then the two angles are congruent. Let's do the same thing we just did. I'm going to pick number 5. Is this obtuse, right, acute, straight? What is that?
Acute.
Acute. So it means its angle is less than what? 90. I'm going to make it 50. And if 5 and 4 are complementary, what does that mean for angle 4?
45.
It's how much?
40.
40 degrees. If I say that angles 6 and 5 are also complementary, what does 6 have to be?
50.
Or, wait.
What is, one more time, these are complementary.
Yeah, 40.
40. So that's got to be 40. So now what do we know about 4 and 6?
They're
They're congruent, okay? It said that if two angles are complementary to the same angle, that meant that 4 and 6 were both complementary to 5. If they're complementary to the same angle or congruent angles, then the two angles are congruent. We're going to use these in some proofs so you can see how we can use them, but there's the congruent complements theorem. Yes, ma'am? All right. The linear pair postulate, we have been using this one in problems for a while, but now we have a title to it, a reason, okay? It says that if two angles form a linear pair, then they are supplementary. We've known this for a while. We've been using the fact that if that is a straight line, 180, a straight angle, then these two add up to 180 right here. We've been using that all along. We have now a title that can go in a proof, linear pair postulate. Next, last one, I believe, yep, is called the vertical angle theorem. Back up. It's called the vertical angle theorem. This just says that vertical angles are congruent. Which ones are vertical angles?
Ones that are across from each other.
And they are what numbers?
Like 2 and 4.
4, 1, 3.
Okay, so angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. Okay, that looks like a 4 right there, by the way. There we go. So now if we need to use this reason in a proof we will now see some vertical angles in proofs, we'll see some linear pairs in proofs, and we might see some complementary and supplementary angles in proofs. What I would do is I would have your postulate book sitting out in front of you with the unit one, the ones we're using right now, because it's most likely those are the ones you're going to be practicing on, so that you know what reasons that you have. If it's like when you go to the refrigerator and you say, I want to make chocolate chip cookies. The first place to go to figure out if you want chocolate chip cookies, if you don't have that memorized, the recipe memorized, is to go get the book out. And then go to the refrigerator and say, well, I need chocolate chips. Do I have any? I need this. Do I have any? So have the book out that tells you what you need when you're going to go search for it, okay? And I'm equating proofs with chocolate chip cookies, by the way, because they're both good. All right. All right, let's do some proofs. I have this one on your page. I'm going to give you some advice here. It says we can now use all of those new items in proofs, and we talked about that already. I am suggesting in words now, make sure you know them well. Don't just rely on that book to make sure you read over them often. If you wanted to, let's go back to the chocolate chip cookie analogy. If you're at the grocery store and you want to make chocolate chip cookies and you don't have your recipe book, it's better if it's in here so you know, oh, I need chocolate chips, I need flour, I need sugar, I need eggs, and so forth that you need. So if you have it in your head, you'll be much faster at making your cookies. Even if you had it memorized, you wouldn't even need it at home either. You can go faster. And it will be less frustration. Make sure make sure they're in your postulate book. You can use them on proofs and on tests. You're going to be able to have that book in front of you during your tests when you're doing your proofs. I am suggesting that only the postulates and no notes. I'm going to tell your parents that you can't write. Remember I told you that on your test you're going to have all those proofs. Any one of the proofs, you can't write all the proofs in your postulate book. And then just copy one of them. All right. When you're doing proofs, make sure you have your postulate book open. Those are the reasons. The reasons that go in your proofs are right there in your postulate book. I actually should have called it a proof book. All right, we're going to do this one. This is number 5 on your homework, so go ahead and get that out. Number 5 on your homework, we're going to do it together. This is going to be a 2-column proof. Okay?
We only have about a half an hour.
Thank you.
Wait,
No, it's only 2. You leave it. 2:30.
2:30.
Okay, all right, here we go. Let's go.
where are we at?
2.5.
2.5, number 5. It's the very first one. We're going to do it together. It says to solve for x. You have been doing this one all along, but now you have some postulates that tell you why to do this. All right? Number 5. I want you to, on your number 5, to give yourself a 2-column proof. Okay? What equation can I set up from this? What equation can I write?
137 plus x plus 6 equals 180.
Okay, that's what I'm going to write. These two add up to 180, don't they? All right. So 137. Oh my, back up. 137 plus x plus 16 equals what? 180.
Can we say that's given?
You can't say that's given. You could do this. If you wanted a given at the beginning, we can make this one be number 2. If you wanted to go like this, and for number 1.
Do you have to do that though?
I don't think so. We can just do diagram.
Wait, why is that one given?
Given. This is not the given right here, by the way. This one
Because
is
it doesn't
not the
give
given.
you-
We actually did some reasoning to come up with this one. There is a reason for this one. Why are we allowed to say that these two add up to 180? We just talked about it.
Linear pair postulate?
The linear pair postulate told you could add those two up to be 180.
What's the...
So we don't have to list a given though for this if we don't want to.
I'm going to say we probably should. We probably should put the diagram as given. Yeah. Okay. Amy, you had a question. Where's what?
What's the abbreviation for linear?
Good job. I'm just going to do linear pair.
Just linear pair. Okay. I just want to know what the abbreviation was.
If you want to put postulate, P-O-S-T, that would be fine too. But
Like, is there an abbreviation for linear?
not that I know
pair?
of. Just
Okay.
linear pair. That's supposed to be an R, not a P.
Oh wait, I have to put
Okay. All right, number 3.
the.
Number 3. Now we just solved the equation. Now we just solved the equation. And there's going to be one of these that this thing we're going to go over today that no one has asked me about except one mom called me. We should have had some students calling me.
Oh.
I guess one student did call me because it's my house, but no one else.
What?
All right, I have to put together this 137 and this 16. How do I put together the one? If you were just doing algebra, we would add them together and combine the like terms. So what is 137 plus 16?
Wait.
143, right?
Wait.
No,
What are we doing?
153.
Yeah, 153.
Yes.
Yeah.
Plus x equals 180. But what in the world reason can I give for that? That's none of the reasons. Did I add? Yes. Did I use the addition property? No, because I didn't add on both sides. There are 2 reasons you can give. You simplified the problem. You could use the word simplify. You also,
Wait.
Go ahead.
That's what we did because I was trying to write something down.
No
So
problem.
what did we just do?
so we combined
137.
the 137 and the 16, and we made the 153. What reason, right now we're trying to discuss what reason did we use.
I don't know if I wanted it. Or was that the one I didn't get to finish before I left?
This is not one we've done before. This is the new one today.
Oh, I was
But
thinking
it's done something
it.
like that.
We might have done one like it, and no one said, Mrs. Dodds, we don't have a reason for that. Can we use addition property? We can't use addition property because we didn't add on both sides. You have to add on both sides. So we simplified. Or combine like terms if you want to write it like that. Okay? Now what are we going to do?
Subtract the 153 over the other side.
So what is 180 minus 153?
127. Or no, 27, not 100. Just 27.
Do we agree? She agrees? I saw Josie shake her head. X is 27, and what reason did we give? What reason is that?
Subtraction.
Subtraction. Property. All right. We're now starting to add this. We just used something like linear pair postulate. There's another one you can use. I'm going to give you a little hint if you want to write something down. If I had 2 lines like this and I had that x and this is not like x, maybe if I did it like this. Maybe if I did 25 and 5 plus x. What postulate could I use to say that 25 equals 5 plus x? We just went over it in your book.
I forget what it's called. I know what it is, but I forget what it's called. Congruent? No.
What kind of angles are these?
Right?
No, they're-
So my pictures are really good in your postulate books. What kind of angles are those?
Vertical.
Vertical.
Yeah.
This is the vertical angles theorem. So what I want you to do is look at number 6. Jot down on number 6. Are those verticals or are they linear pairs?
Vertical.
They're vertical. So you're going to use vertical angles. Is it theorem or postulate? I think. There. I thought. Okay, I said it right. I thought. Yeah, vertical angles theorem. Okay. Give yourself just a little hint there. Let's move on. Ryan says we got to hurry. I agree.